Hello and welcome to the new video on adding and subtracting fractions. Now, if you're not used to adding and subtracting fractions, this might not be the video for you because I'm going to touch very briefly on the basics of adding and subtracting fractions, but move on to a little bit more advanced ideas in terms of different forms of problems when we're adding and subtracting fractions. But without further ado, let's get started. When we're adding and subtracting fractions, the basic concept that we have to keep in mind is that we're always looking for a common denominator. So for our example, let's start off with a pretty simple basic fraction like 1/2 plus 1 over 3. Now when we have 1/2 plus 1/3, we can already see that the common denominator that we're going to have to look for is 6. And so in order for us to get 6 on the left addend here, we have to multiply both the numerator and the denominator by 3. And for the right addend, we're going to have to multiply the numerator and the denominator by 2. And so when we do that, of course, we can, you should already know or be used to getting the equivalent fractions of 3 over 6, because 3 times 1 is 3 and 3 times 2 is 6, plus the right addend is 1 times 2 is 2 and 3 times 2 is 6. So that's the basic concept that you all should already understand. And of course, now that we have the common denominator, we can get the answer, which is 5 over 6. And then there you go, that's your answer. But one of the things we talked about in class was the idea of visualizing what we're looking at. And so how can you visualize something like 1/2 plus 1/3? And what does that exactly look like? Well, let's go ahead and draw 1/2. So I'm going to go ahead and draw a little square here, and forgive me because my drawing skills are very poor. But if I drew a square here, and I was to shade in 1/2 of that square, this is roughly what it would look like. Let me shade it in with a different color here, or I can shade it in like this. So if we have 1/2 of this square, we can see that that red portion there is 1/2 of this one whole square. Now, what we have to do next is be able to visualize, well, how do we add a third to that? How am I going to take 1/2 of this square and then add a third? What most people will do is they'll go ahead and try to draw another square, and then they'll try to picture what it looks like to have a third. And then this is where people get stuck. How do you take this part and add it to this part and come out with 5/6? Well, that's a little bit backwards in my opinion. There's a much easier way, and that is to, instead of dividing this, or instead of drawing another square and dividing it into thirds vertically, I like to draw another line horizontally, or another set of lines horizontally. So in this case, I'm going to draw a line this way. Oops, I should get my pen here. I'm going to draw a line this way, and then one more this way, because now what I've done is I've taken this same square and I've added, or I've split it up into thirds, and now all I need to do is make sure that I'm going to shade in 1/3 of this square. Well, we can already see that 1/3 of this square, or 1/3 of this this division that I've done of the square, takes up 2 of these pieces. And so since this one's already shaded in, I'm going to go ahead and shade this piece in and that piece in, because 2 pieces equals 1/3. And well, what do you know? Look at this: 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6. And so we can see very clearly this idea. Let me get my pen out here again. We can already see that, yes, indeed, 1/2 plus 1/3 does equal 5 over 6. We can visualize that very easily. I went ahead and deleted all of what we had before, but the same ideas apply to when we're subtracting fractions. So let's go ahead and use the same fractions we were using before. Again, let me use my pen here. So when we're using the fractions of 1/2 and 1/3, let's go ahead and subtract those same fractions that we were using before. Before we were adding them, but now we're subtracting them, and the same rules apply. We need to get a common denominator, and so we're going to multiply this fraction, the numerator and the denominator, by 3, and the fraction on the right, we're going to multiply the numerator and denominator by 2 in order to get that common denominator of 6 that we're looking for. Oops, that should be a 2. And so when we go ahead and take care of that, what we get for this left addend, of course, is 3 over 6. And what we get for this right addend is 2 over 6. And since we're subtracting, we already know that 3 minus 2 should equal 1 over 6. And so computationally, piece of cake. This should be pretty easy and basic to all of us. But again, I want us to be able to visualize what this looks like, being able to subtract 1/2 from 1/3. And so let me go ahead and try this again. I'm going to draw my my unartistic square here. Not very perfect, but it'll work for us. And so I'm going to take 1/2 of this square and go ahead and fill it in with the color red. And so now I clearly have here 1/2 of this square. And again, the problem that a lot of people run into is, how do you take 1/3 away from that? And some people like to draw split it up horizontally into thirds, and they run into a problem because it's hard to visualize. But again, what I like to do is, instead of drawing lines vertically, again, I like to draw lines horizontally to divide this square up into thirds, but in a different way. And so when I do this, I have split this square essentially into thirds. But now when we do that, in addition to the half, we can see that we have this square split up into 6 pieces, which should make sense because we have a common denominator of 6. But now that we've done that, what we can do is go ahead and take away 1/3 of this square. And so again, 1/3 of this square is going to be 2 pieces, right? And so we're going to go ahead and fill in these 2 pieces, or we're going to take away 2 pieces that represent the 1/3. And so if I take away that piece and that piece, what we are left with essentially is this 1/6, which makes sense because that was our answer when we looked at the answer computationally. Now, if you've been tracking with me up to this point, we want to move on from those basic ideas of adding and subtracting fractions. And so we want to be able to understand the basic concepts and maybe even stretch our understanding of fractions by looking at more and more complex kinds of problems when we're adding and subtracting fractions. And so the question that might come to mind is, hey Matt, adding and subtracting fractions are pretty basic. How can you get more complicated than that? Well, a way I like to challenge my students is to take away certain pieces that we're used to having and trying to derive the answer that way. So for example, let me show you this problem here. What if we had a problem like this where, yes, we are adding 2 fractions, and I'm even giving you the answer, but I take away one of the denominators. In this case, what are we going to do? How are we going to find what y equals? That's essentially the question that we're trying to get to. And so for a problem like this, what we probably want to do first before we ever try to figure out what y equals is the strategy that I'm going to employ is I'm going to take this improper fraction here, this mixed number here, and change it into an improper fraction and hope that that'll give me a better understanding of what to do next. And so if I were to change this mixed number into an improper fraction, of course, you should already know that the way you changed a mixed number into an improper fraction is you multiply the denominator with the whole number in front, which is 1. So 9 times 1 is 9. And we're going to add the numerator, which is 9 plus 4 is 13. And so this mixed number as an improper fraction comes out to 13 over 9. And so after I do that, I'm going to go ahead and rewrite what I have on the left side of this equation, which is 7 over 9 plus 2 over y. Now, when we go ahead and do that, we can already see that this y here, this variable y here, we need to make it into a common denominator of some sort. Because right now, as it stands, it doesn't work very well. If y were equal to 9, 7 plus 2 does not equal 13. And so we know already that y does not equal 9. But what can it equal? We can deduce what y could equal if we can figure out how to make this numerator, 2, into a number that we need. Well, let's take a look at this. Since 7 plus whatever this numerator is, and whatever we need it to be, is equal to 13, we can already see that, we can already deduce that we need to somehow make this numerator, in this case a 2, into a 6, so that 7 plus 6 could equal 13. Well, what do we multiply with 2 in order to make it a 6? And that should be pretty basic if we think hard enough, right? How the way we make a 2 into a 6 is we multiply it by 3. And so whatever we do to the denominator or to the numerator, we have to do to the denominator. And so we can deduce that if we have to multiply 3 and 2 to get a 6, we have to multiply 3 and y in order to get a 9. And so the only number that we can have as a denominator in this case for y is 3, since 3 times 3 is 9. And so that's your answer. Your answer is y equals 3. Now, if you don't believe me, go ahead and do the math. We can go ahead and do the math on the side. Let me try a different color here. If we had indeed 7 over 9, and we were adding this to, let's try this. 2 times 3 is 6. And then if y were indeed equal to 3, 3 times 3 is 9. If we're right, this should equal the answer of 13 over 9. And so 7 plus 6 is 13. And well, what do you know? You don't do anything to the denominator, and so that's your answer. And so we can see that that is indeed our answer. Well, let's try one more example. If you didn't understand this the first time, go ahead and rewind the video and watch this example. But we're going to try a different example where instead of taking away this denominator, I'm going to take away a numerator. And so let me go ahead. Oops, I should go ahead and try to delete this example here and move up. Let's try to move up a different example. Let's go ahead and move all this, and let's try this example here. How about that? So I have this other example where I am instead going to be taking away a numerator from you. How are we going to figure out what this numerator equals? Well, we can already see that this second addend does not have the same common denominator. And so my strategy before I even try to figure out what y equals is to get this to a place where all the denominators are equal and it's easy for us to visualize or to imagine what to do next. And so let's go ahead and do that. In order for me to change that second addend into, or the denominator of the second addend to an 8, what do I have to multiply with 2? Well, we have to multiply this by 4. And again, whatever I do to the denominator, I'm going to do to the numerator. And so the new resulting equation, in this case, would be y over 8, since we haven't figured out what y equals, plus 1 times 4 is 4, and 2 times 4 is 8, and all that is equal to 5 over 8. We accomplished one thing. We have gotten all the denominators to equal 8, and so now we can clearly see that whatever y equals, if we add it to 4, we get 5. And if you think hard enough, we can already deduce that, hey, there's only one number that y could be, that if you add it to 4, it equals 5, since we already have the common denominator. And so that is y equals 1. And that is our answer. And if you don't believe me, you can try adding that again. I'm going to try that in the same color that we were using before. And again, if y does equal 1, let's go ahead and try that. 1 over 8 plus 4 over 8. And if y does equal 1, this should equal 5 over 8, right? And of course, it doesn't take a genius to see that, yes, 1 plus 4 equals 5, and the common denominator remains the same. And so that is how we get our answer.